Hello students, welcome to the chemistry lecture series for the CBSE students. In the last video we discussed the Henry's law in the chemistry chapter 2 solution lesson. So today we are going to discuss the application part, that is a conceptual application part of the things. Yes, gas and liquid. Applying the Henry's law. This is one of the conceptual applications. So in the last class we discussed the Henry's law and its applications, everything. And this class we are going to solve some few NCERT problems. Yes, this conceptual applications, the Henry's law statement, the partial pressure of the gas and vapor phase is directly proportional to the mole fraction of the gas in the solutions. If we express in terms of formula PA, partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in solutions. So proportion is you have to put on concept P A, suppose if it is A is a gas which is equal to KH into Ka. The KH is known as Henry's constant. So we are going to apply these applications in this NCERT problem in text questions 2.7. Let us solve the NCERT in text questions 2.7. Henry's law constant for CO2 in water is 1.67 10 to the power of 8 pascals at 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atm, that is atmosphere, carbon dioxide pressure at 298 Kelvin. So here they are asking calculate the quantity. So first we will write the Henry's law formula. Henry's law is partial pressure is directly proportional to the mole fraction. Partial pressure is equal to Henry's constant in the mole fraction of CO2. So here given data, Henry's constant is given as 1.67 10 to the power of 8 pascals and quantity is asked, that is amount of CO2 in 500 ml, that is a question. Okay, yes. What is the formula for this case? Here pressure is there, Henry's constant is there, amount only they asked. So partial pressure of what? This one is given as a partial pressure of CO2 is given as 2.5 atm, whereas the Henry's constant is 1.67 10 to the power of 8 pascals. These two are both are in different units. First we have to convert either to pascal or to atmosphere. So here you have to know 1 atmosphere is equal to 1 10 to the power of 5 pascals. Here you have to use it formula. So in this case, mole fraction of CO2 equal to P by KH. Substitute in the formula. P is given as 2.5 into 10 to the power of 5 pascals by 1.67 10 to the power of 8 pascals. Pascal, you can cancel it. So 10 to the power of 8 is there, so it comes 10 to the power of minus 3 is equal to, if we simplify this one, we are getting a 1.5 into 10 to the power of 5 or something else into 10 to the power of minus 3. So here we know mole fraction of carbon dioxide is find out. The next one we have to find out NCO2 by N of CO2 plus N of H2O is known as mole fraction of CO2. This is a formula. So you are substitute what? N of CO2 by N of H2O. Compared with the H2O and CO2, the CO2 is very negligible. You have to neglect that one. So we have to find out the number of moles of carbon dioxide. Here number of moles of water, already we know that what N is equal to given mass by molar mass. Given mass is 1000 gram, that is 1 liter, by molar mass of water is 18. So if we simplify this one, we are getting a 55.55 moles. So, but the question is what? Calculate the quantity of carbon dioxide in 500 ml. So this is 1 liter. If it is a 500 ml, means divided by 2, we are getting approximately 27.78 moles. There you have to substitute here. So N of CO2 is equal to 1.51 into 10 to the power of minus 3 into this 27.78. If we multiply these two things, we are getting an answer of 1.83 grams. That's the answer. The another one NCERT problem is 2.13. The partial pressure of ethane or a saturated solution containing 6.56 in 10 to the power minus 2 gram of ethane is 1 bar. If the solution contains 5.00 in 10 to the power minus 2 grams of ethane, then what will be the partial pressure of the gas, they are asking. So we have to write the formula. Mass is directly proportional to the partial pressure of the gas. Mass is equal to Kh into P. If we use the formula, there are two cases. In the first case, what will be there? Yes, mass is given 6.56 into 10 to the power of minus 2 gram, which is equal to constant, Henry's constant, into partial pressure is given as a 1 bar. This is the first case. In the second case, .00 in 10 to the power of minus 2 gram of ethane, which is nothing but Kh into P. They are asking this partial pressure only. So equating these two things, so partial pressure is equal to 500 in 10 to the power of minus 2, cross multiplications, we are getting this one. So 6.56 in 10 to the power of minus 2. So you have to cancel these two things. If we simplify this, yes, the partial pressure bar, this one is given as a 0.762 bar. This is another problem. So in this case, the mass of the given mass of a gas is directly proportional to the partial pressure of the gas. Proportional is you have to put on constant Kh. First case, there are two cases. If it is a 6.56 gram of ethane is what? 1 bar. In the second case, 5.00, the Kh is what into what will be the partial pressure they are asking. So we have to equate these two things. We are getting the cross multiplications, we are getting what? P is equal to 5.00. The Kh will be cancelled. If we simplify this one, we are getting a 0.762 bar. This is the answer for the 2.13. Yes, let us see the another one, NCERT one problem 2.35. Henry's law constant for the molarity of methane in benzene at 298 is 4.27 10 to the power of 5 millimeter of mercury. Calculate the solubility of methane in benzene at 298 Kelvin under 760 mm of mercury. So in this case, we try to understand what are the given datas. Given data, Henry's law constant is given. Kh is what? 4.27 10 to the power of 5 mm of mercury. Calculate the solubility they are asking. That means mole fraction we have to find out. Solubility is asked. The pressure is given as 760 mm of mercury. So you have to use the formula P is equal to Kh into chi. So here is these two are given. Kh chi is equal to P by Kh. Pressure is given as a 760 mm of mercury. Both are given the same unit. We have to see the pressure unit, millimeter of mercury. In both the cases, there is no problem of conversion of pressure. So the Kh is given as 4.27 10 to the power of 5 mm of mercury. If we cancel these two things, when the 10 to the power of 5, when it comes to up, it will be 10 to the power of minus 5. If you cancel these two things, 177.9 into 10 to the power of minus 5 will comes. If you express in scientific notation as 1.7, when it what 7 more than 5, then you have to convert it to whole number, 1.78 into 10 to the power of minus 3. So here this is the answer of what? Mole fraction of methane in benzene. Mole fraction of methane in benzene. So that's the answer for this one. So apart from these problems, there is also one theoretical based questions. Yes, the next one is a theory based application questions, conceptual applications. In the NCERT questions 2.11, why do gases nearly always tend to be less soluble in liquid as the temperature is raised? So we know that when gas soluble in liquid, we can call it as dissolution. Say for example, gas in liquid, see that one solution plus liberation of heat will evolve. So this process is known as dissolution. So here, why do gases nearly always tend to be less soluble in liquid as the temperature is raised? So in this case, when the gas dissolves in liquid, if you raise the temperature, what will happen? The equilibrium shifts backward. The equilibrium shifts backward because it is an exothermic reaction. Because it is an exothermic reaction, that's why what? The gases are what? Less soluble in this case. That's all. Thank you, students. If you have any questions, please comment in the comment box. Thank you, students.